Welcome back to Basic Biostatistics 2. In this session 4, I will show you how to use t-tests and their corresponding non-parametric tests in SPSS. The first video will be about a one-sample t-test and explain you when do we need a one-sample t-test and how to interpret the findings. Let us assume we would like to compare the diastolic blood pressure of month 1 of our dwarfs according to a reference value. The reference value can be any value of a treatment criteria or guidelines list or any value we know from previous research. Let us assume we know from previous research and studies that the mean diastolic blood pressure value of MPH students at the University of Eastern Finland is around 95. Now we would like to find out whether the diastolic blood pressure mean value of month 1 of our dwarfs is statistically significantly different from the mean value of the MPH students. Our null hypothesis is logically that there is no difference in diastolic blood pressure of month 1 of our dwarfs and the diastolic blood pressure of MPH students. Important is the t-tests require that the continuous variable, in our case diastolic blood pressure, is normally distributed. If the continuous variable is not normally distributed, we cannot use t-tests, but we need to use a non-parametric test. Luckily, we know from the previous sessions that diastolic blood pressure of month 1 is normally distributed, so there's no problem with violating the assumptions of the t-test. We can find t-test and one sample t-test under Analyze. We go to Compare Means, and we see here the second option says one sample t-test. Once we click on one sample t-test, a new window opens called one sample t-test, where on the left hand side we have all the variables of our study. As we are interested in diastolic blood pressure for month 1, we select a particular variable, we click on it, we move it to the window on the right, and you see now we have selected as a test variable diastolic blood pressure of month 1. The only thing we have to do now is we have to tell the program what's the test value, what's our reference value. We assume that the reference value of MPH students is 95. As you remember, this reference value comes from previous research or previous guidelines. The test value, the values you're going to test the diastolic blood pressure of dwarfs, we have to add here under test value. We click on the window and we write 95. From this point on, SPSS, the one sample t-test, will test whether the mean diastolic blood pressure value of month 1 statistically significantly differ from 95, the average mean or the mean value of diastolic blood pressure of MPH students. We click on OK, and SPS opens the output window where you can see the results of this analysis. As usually gives you first a summary table. We see there are 60 observations who have blood pressure. The mean value of our dwarf is 97.97, the standard deviation 4.158. How big is our test value, and is this difference significant? First of all, the one sample test table, the output table, gives us a lot of different information. It tells you first that the test value is 95, so we tested the value of our dwarfs against the test value of 95 of our MPH students. It gives you a value t. This is the value of the statistical test. It's not really important for you, it's not really necessary. The degree of freedom is usually number of subjects minus 1. It's also not that important, and you may know what does it mean from previous studies. The most important thing is the significant value. That's the p-value, a two-tailed p-value of 0.000, which means far below 0.05. You also remember that if the p-value is smaller than 0.05, we reject the null hypothesis. In our example, this means that the alternative hypothesis is true. This means that yes, there's a statistical significant difference of the mean diastolic blood pressure value between our dwarfs and MPH students. We can all see that the mean difference is about 3, 2.967 in general, and we have the lower and the upper confidence limits of that difference. So we are 95% sure that the difference is at least 1.89 millimeter mercury. In best case and worst case, the difference is even bigger, it's 4.04. This is how we interpret the one sample test results, and this is how you run a one sample test. Thank you very much.